if you're looking at like what your experience is and these job descriptions, like the best way is just having a good match and then being able to just talk confidently and just really understand what you're doing, really understand why you're using these different models, why the data needs to be cleaned this certain way, and really understand, frankly, cleaning your data. That's like the most important thing I think I've learned.
Welcome to the Astronomers Turned Data Scientists podcast. I'm Joseph Ahern, and I've been a data scientist for 2.5, almost 3 years now.
And I'm Jeff Silverman, and I've been a data scientist for 8 years now. And today we have on Tom Kirsh. Welcome, Tom.
Hello, thanks for having me, guys. I've been a data scientist for almost 6.5 years.
Awesome. So, do you want to start out by telling us how you got into astronomy?
Sure. So I was reflecting upon this the past couple weeks because it's been a while since I reflected on it. And I think it started back when I was in high school and I was starting to think about, okay, what do I want to study in college? And I was looking at aerospace engineering, I was looking at physics, and it was all coming down to like I've always been pretty good at math. I've always enjoyed applying math to solve problems and describe how the world works. That led me to me deciding to pursue physics as a degree because I wasn't 100% certain kind of what I wanted to do. I think my dream job, which doesn't exist, would be space exploration of hopping around planets, seeing new worlds, right? How cool would that be?
Yeah.
I feel like that's a lot of people's ideal dream job, right? But that didn't exist. So I was like, okay, what's the next best thing? And that was astrophysics. So I ended up going to the University of Illinois, and they didn't have an astrophysics degree. It was physics and astronomy. And I thought physics was a little bit more broad. So if something happened, I could switch around to a different degree pretty easily. But it was just that love of I had a really great high school teacher in physics and calculus, and it was just everything was super clear. I could see how things applied to the world, and I was like, okay, this is awesome. It's like sparking my imagination to go more. So I was like, okay, well, let's do this in college and just learn more about it all and see where it goes. I think part of it too was like physics is a pretty hard degree, and I was attracted to that challenge. So, so just yeah, just the challenge of that, right, was pretty exciting. But I knew Illinois was pretty had a strong program for semiconductor physics and I guess solid state physics. But that really wasn't what I wanted to do. I was definitely more attracted to the astronomy and all the astrophysics courses and research. So I focused a lot of my attention on that, right? And then Joseph briefly mentioned I got involved with the Astronomical Society mainly because I'd heard if you got involved with the leadership, you had keys to the observatory and they trained you how to use the telescope on campus. I was like, that's awesome. I want to be able to do that, right? So that's that's how I started getting involved. And then I loved just all the events that we had and talking about astronomy with a bunch of kind of with more civilians and other astronomers and getting to know the department and all the professors there and all the other fellow students. It was just a lot of fun. And I did get keys to the observatory and I did get trained. So I could go up whenever I wanted to go explore if somebody wasn't there. So I took advantage of that on cold nights. Yeah, that's kind of where my initial love for astronomy came from. That desire to go explore deep things, desire to have a challenge, right? The love of math and applying mathematical models to describe how the world works. That's where it came from.
Nice. That's awesome. Yeah, definitely. Getting keys to an observatory of any size is always a big step and always awesome. So I understand that motivation for sure. Okay, so listeners will know where I'm going with this question in a few minutes, but you're getting toward the end of your undergrad degree. You're super into astronomy. You've got keys to the telescope. You're involved in the Astronomy Society leadership. What's your thought process? Most people assume that in this situation, you would start applying to astronomy grad schools, right?
Right? And that's exactly what I did.
Okay.
Um, I was, let me see, I think my sophomore year, I started doing research with a professor in nonlinear dynamics. So not astronomy related at all, but it was really interesting too. He was trying to model wireless power transmission using nonlinear dynamics, right? A lot of nonlinear equations and oscillators to accomplish that. And it's like, okay, maybe there's some tie here with nonlinear dynamics and astronomy, but I wasn't really seeing any other people doing research on that. So I was like, what do I know? So I got involved with that, and through that, I got better at MATLAB programming. I took the first computer science class I took was my freshman year, and we learned C++ and MATLAB. And I absolutely hated it because it made no sense. I did not understand how to think about problems or approach it or translate English into C++ code, any of it, right? So I was like, okay, this is terrible. If at any point in my future career, I need somebody to do programming or coding, I'll just hire them. I'll do the fun stuff, like with pencil and paper. We'll be set, right? But as I matured in undergrad and got towards junior year, and I was starting to think about like, okay, what are grad schools looking for? What kind of research are they looking for? And what do I need to do in order to get some of these undergrad research positions? Well, the answer was learning Python and how to code in Python because everyone's telling me all the physics research, all astronomy research, especially, is all done in Python. So I took a class. The first Python class I took was this informatics slash astronomy class because it was taught by a professor in astronomy who was also in like the computer science department or maybe the informatics department. I forget. But that class was like foundations of data science. And I didn't know data science was a separate thing. I was like, okay, great. It's analyzing data with Python. That's excellent. That's what it was, right? I was building a solid foundation in working with data sets in Python, understanding matrix operations and how to look at data, right? Visualize data, doing some basic matplotlib, plots and everything and all that, right? And then towards the end, kind of getting into machine learning a little bit more. I was like, okay, this is kind of interesting. This is good. There was a follow-up class the next semester that I took, which expounded on that more and got into a lot more of the machine learning modeling. And so I was kind of exposed to like the random forest and support vector machines, and some of these algorithms and how to apply them. I was like, oh, this is kind of cool, like learning some of this stuff. And I was like, okay, I could see how this is applicable in astronomy in grad school. And maybe down the road, right, I can see how that translates to different industry positions if for some reason I decide, because I was like, I don't know, I don't want to be a professor completely all the time. I was like, okay, it could translate there, right? But I definitely wanted to do more astronomy research. So junior, I think my senior year, I started doing a little bit of astronomy research as I was applying to schools. And then by the time I submitted all my applications, I submit a lot of applications. I got rejected from all of them. So I was like, oh, shoot, what do I do now? Because this is terrible, right? I was like, oh, shoot, all my friends are going off to their grad schools, or some of them weren't. Some of them were doing other things. Some of them were like, okay, we're going to take an extra year. So I got some feedback from the grad schools I applied to, and one of the suggestions, pretty much the only suggestion was like do some astronomy research. I was like, okay, yeah, because I've been working a lot on this wireless power transmission. I was like, okay, well, I have programming here, right? And I've had these classes in Python and such. So I was like, okay, let's go find some professors doing actual astronomy research. So I met with two professors, and one of them was working on a project of classifying galaxies as different parts of large scale structure, which I was very interested in. And the other one was doing something with like helium bubbles in early cosmology. I don't remember that a lot. It was been a long time ago, and I was trying to plot a simple graph on there, but I was struggling at that point. But the more interesting one was the trying to predict. We were trying to classify galaxies as different parts of large scale structure, right? And so that was kind of exposing me to classification more and more. And so when I did that for a year, all three research groups for a year, and I was getting ready to apply again for another round of grad schools. And I submitted all those applications. I was looking for people who were doing astronomy and machine learning research because it's like, okay, this stuff is actually really interesting. I like this. I think it's going to be, it could be, has the potential to be a good way of modeling the universe and all these, or just working with it. So that's what I like to do. And I go through that round of grad school applications again, and I get rejected by all of them again. So I was like, okay, I don't want to go pay a bunch of money again for applications and get rejected a third time. So it's like, okay, what is out there? I was like, well, maybe I need to take a little bit more of a deeper look at what I'm actually interested in and what my actual goals are. And thinking through it, I realized that kind of the PhD in astrophysics, I was viewing it as a stepping stone towards a data science job down the road, right? And kind of with that realization, I started looking on Indeed and searching for junior data scientist positions just around like, okay, well, what are these people looking for? And how do I have it? Or what can I do to learn these things? And I was starting to see that there were junior data science positions open. And I was starting in the Chicago area because that's where I'm from. It was close to U of I. And I started applying to a bunch of them, really heavily relying on Python, my Python and MATLAB knowledge, and the minimal experience I had from this one research position. And I had a couple interviews, one with an insurance company and one with some like credit card financial company, but it wasn't a lot. And I got one offer. I didn't think it was going to lead where I wanted to go, so I did not accept it. And so I started kind of expanding my search outward, right? I didn't want my family was all in Chicago. I wanted to be close, but I was like, okay, well, maybe I just don't have the experience yet. Maybe there's something a little bit further away, right? So I started looking at Michigan and then I expanded to Minnesota also. And then in Minnesota, I saw this position in their Institute for Health Informatics that I applied for and I interviewed at. And it was one of the ones I felt pretty confident in the interview. And then they ended up offering me that position. And so I moved to the Twin Cities for that.
That's awesome to hear you go through all that. And one of the main reasons we wanted to invite you on is because so far all of our guests have transitioned from PhD or later into data science. And you did it earlier in terms of like from after your bachelor's degree, but it wasn't a straight path exactly. It took a lot of soul searching and rounds of applying to figure that out. But I think you still got in before all the AI hype, and so maybe that was a blessing in disguise so that you can get several years of experience before all of that, like that big wave of people coming in. The one I wrote in now. Yeah. So
Yeah, that's true. I don't know. Yeah, when that big wave came, yeah, I don't know that I would have been able to do it.
yeah, so do you want to go into your experience on the first job you had and continuing to grow in your data science skills and getting that taste of industry as well?
Yeah, absolutely. I had that offer, the offer at the University of Minnesota, and I accepted it because one, it was a great job. It was in the data science field. They knew that I didn't not have a big background in computer science, but they were like, okay, you have some project experience based on the interview. We think you can pick everything up very quickly, which I was like, yep, absolutely. So it had like that kind of growth opportunity, but also like I could contribute. The second factor was that the university had a scholarship for a 75% off tuition, which I ended up using maybe a year or so after I moved here to get to start a master's in computer science. So, like you talk about the Joseph, you mentioned the wave of AI and everything. And I think I also started this position kind of before a lot of these data science masters started picking up and like all colleges started having more of them. And then even trickling down into like I see now like undergrad programs, right? That was helpful and good timing there too. There, I worked for two professors in the Institute for Health Informatics. And my boss, as I was looking at this and talking about it with her, because we were both in agreement that doing this master's would give me a lot more of a background in computer science and some of the statistics behind some of these algorithms, just understanding maybe how to think about these a little bit more sophisticatedly. Just really firm up that foundation, right? So I wanted to understand the math behind everything in a lot more detail. And I figured that was the best way. And my boss recommended that I go for the master's in computer science over the master's in data science because that was a little bit more marketable, right? So that's what I did. And I did that part-time for 5 years. And I think that was actually doing it part-time was really nice because I could take one class a semester and just focus on mastering the material a lot more than in undergrad when and also I'm sure your graduate programs where you're taking like 5 classes a semester and trying to balance all of those. So I was working full time, but I could kind of take a little bit more time in the evenings and on the weekends to really learn the material. So, and I will say that was also kind of a nice working full time, moving into that after leaving undergrad was nice because at 5 o'clock, like I'm done. I can leave that at work behind. I've worked really hard to get everything done that I need to. And then I have this time to do hobbies and such. So, which I've come to really appreciate and learn. Like it's really nice and good to have that. So that was the second reason I chose the job. And the third reason is I was kind of ready to leave Illinois and explore a new state. Minnesota has so many, especially in Minneapolis, St. Paul has so many outdoor activities, hiking trails, bike lanes, right? I think they're the number one biking city in the US. And even in the winter, right, people are cross country skiing, they're going ice skating on a lake, which I never did before. And I was like, this is incredible. Just like all this stuff to do outside. And it was also it's not, maybe not as big as Chicago, but I didn't grow up in downtown Chicago. I grew up in the suburbs. But the size of Minneapolis and St. Paul and being in that city I like the urban area also. Yeah. So that's how I chose and my reasons for choosing this job. But as I was working there, it was quite a exponential like learning growth. Like in the beginning, it was really kind of mastering all the tools in Python and MATLAB because a lot of our code base was in MATLAB. So mastering just like the not only the beginner and intermediate weight programming in both those languages, and then not only like predictive modeling, which was most of the work. It was all because I was in two different, like I said, I worked for two different professors and they had two different kind of research areas. One professor, not my main boss, but my, co-boss, her research was all in traumatic brain injuries and PTSD. So everything she was interested in was leveraging national databases to predict people having severe PTSD 6 months after, 12 months after, right? So even up to like 10 years. We had this data set over 10 years. That was really interesting and helpful. But it turns out it's kind of tough to do 10 years down the road, but it's probably also more informative just like in the next 6 months, in the next month. That was kind of the best models that we had for that. So that was like her focus of work. And that was like half the projects I worked on. Related to that, she also wanted me to develop this merging pipeline and application, develop a GUI so that non-programmers could use this. And because a lot of all the data we got, and I hope you guys get your data in a much more better, streamlined way. All the data we got was hundreds of text files or CSV files from a government database that, they had ways to merge them together, but just doing it in like a for loop or even like a reduce function in pandas just crashed crashed it all and ran out of memory, right? So I had to kind of go back to base Python and develop it that way. So I learned really quickly a lot of the inner workings on how to merge how to merge data sets together, which people using SQL and everything are probably like, oh yeah, this is super easy. And it's like, well, it's tougher when you have to write it from base Python. But that's kind of what we had, right? We didn't have a SQL database set up, right? And I looked into like SQLite and doing it, but I think that was just also too much memory for this nice little GUI that she wanted me to develop too, which I didn't know anything about like web frameworks. So I had to learn Flask and Dash to just build this and decide between the two. And I was like, well, everything I'm researching on my own because like I don't have a senior software developer guiding me along this way. Everything I'm researching on my own is like, okay, let's do this. This is how you do it, and just go from there. So that was maybe like the first year or two of developing that and building it, which was just it took long because it was just me and I was figuring out how to do it on the fly. But doing that also, right, that taught me unit testing and how to test all these different functions with it. It gave me more confidence that I could pick things up and learn these new skills relatively, well, maybe not relatively quickly. And then as I got better, like 3 years into the job, I could look back at this stuff as like, oh, actually, let's reformat this and make it a little bit faster. I could do it differently. And so kind of improving performance on that later too, right? And then also like working with Git and learning how to use that to update or to store my changes. And then when I want to add a new feature or mainly adding new features or improve old features, I could do so in an organized way. So that was really interesting. It was really fun. Then the other professor's work was a little bit more, it's very related, all predictive modeling, but her primary focus was on causal discovery algorithms and using graph theory to develop causal models where we could relatively look at which features are important for driving the outcome that we're interested in a lot of cases. And with her, she was forming kind of the start of like a internal data science team. So within the Institute for Health Informatics, there weren't just computer scientists, there were health professors, there were psychology, there was psychiatry, there was medical. So I got to work on some diabetes patients and looking at their glucose levels. I got to work on predicting PTSD in police officers. And then towards the end of that was looking at building like a child PTSD and abuse predictions. If like a child comes into a clinic, what's the likelihood that they're being abused based on these things? And so using the causal modeling to really to not only develop this graph, right? I say graph like nodes and vertices, not like a nice little plot, but develop this graph to kind of really show the relationship between a lot of these variables. Because in the medical field, right, people are trying to like, well, what's causing this, right? And statistically, causal language is a little nebulous, and you got to be careful. But it's good because when you're using when you use that language, you definitely want people reviewing you and saying like, okay, some of this things like, okay, with randomized clinical trials, that's where the confidence, that's like the gold standard now of confidence in saying like, okay, yes, everything equal, this caused this, right? This treatment caused people to get better, right? And so it's kind of using these causal discovery algorithms in observational data. The goal was based on the set of assumptions, we can kind of model those relationships. And so she had some code to not only build those models, but also to use it for feature selection and kind of showing that if we can identify, if we have our target and we can identify the parents and the children and other parents of the children of this target, those are typically the features that have the most information or are most useful in making our predictions. So we don't need, if we have hundreds of other features, we just need the smaller, potentially smaller subset, right? So yeah, we applied that was kind of the foundational code base. So we applied that to all of the projects. And it was interesting. It was interesting to kind of also line that up with what have researchers in psychiatry and psychology and medicine kind of established as like, okay, we know these things are very important in predicting somebody with PTSD. We know these things are very important in predicting abuse. So are the features that are being selected by these models lining up with that, right? And if not, why not? And I think in pretty much all the cases that was the case, that they would be identified, right? And we can get better performance from those models as well. So it's kind of more cutting edge of than I had in undergrad, or I don't know, or elsewhere, I suppose. So it was interesting to wrap my head around that and learn the math behind it too. Like like my first semester that I worked there, because I moved to the Twin Cities November 2018. And so that spring semester, my main boss was like, you should take this class that I'm teaching that teaches you about causal discovery. So I was like, okay, great, let's do that. And I did, and I was like, okay, yeah, I think I got some good understanding of it. And then, like maybe 2 or 3 years later, she was like, okay, I've kind of readjusted it. You don't have to take it for credit, which I was glad. I just wanted to focus on learning at that point, and I didn't want another class on my plate. But actually, I don't think it would have counted either for my degree. But she kind of revamped it, and it's just now that I've been working with it for a lot longer and kind of had that more experience with it, it was really valuable to go back and kind of learn all that stuff more in more depth.
Well, thanks for walking us through all that. And yeah, it sounds like quite the learning curve. I mean, not only from the computer science side, the data science methodology, causal inference side, but even the health side, right? The medical side is a whole
Yeah,
other learning curve. And not I would say not abnormal for anybody going from sort of physics or astronomy academia, right? That's what we know, and most data science jobs do not have to do too much with physics or astronomy, so you're always going to have that domain knowledge you need to ramp up on. You're always going to have to learn new tools, new techniques. Even if you did machine learning or more data science heavy research, there's always going to be new stuff out there. So that certainly, I think, is fairly common across the board. I think maybe you had a steeper, perhaps bigger learning curve than others going into quite a different field. But I was kind of curious to hammer into or dig into that a little bit deeper of, putting my hiring manager hat on. I've hired data analysts, data scientists, folks right out of undergrad, and your situation coming with a bachelor's of physics and astronomy, doing a little bit of astronomy research, doing a little bit of physics research, having some CS classes and some coding skills. How do you pitch that to, I'm going to work in health informatics for a huge university? Like, how did you, yeah, get your foot in the door? How did you, spin some of those skills to like, yes, I can, like you said, learn this stuff quickly. I can use my MATLAB and Python coding skills and learn more of them and apply them in this new field.
sure. So, yeah, when I applied for that position, I leveraged heavily the work that I had done using Python to develop this random forest classifier to classify galaxies as different parts of large scale structure, right? And I was like, yeah, I'm familiar with these other methods too, and it ended up being other parts of the pipeline. And I kind of walked through the process of that project, right? All the different steps from where did I get the data? How did I clean the data? And I would say for that project, my data did not need a lot of cleaning. And I'm not sure how much data cleaning you guys had to do with in your astronomy research, but from what I remember, it's not as extensive as the data cleaning I have to do for in the medical field, because I don't really remember doing a lot of text cleaning in astronomy and trying to match misspellings of anxiety across and clean that up. But I really described that project. And then I also said the same thing I told you guys at the beginning of like, well, I chose to do physics because I like learning hard things and I like the challenge. And I've conquered that in doing the physics degree. I've conquered that in finding research. I've conquered that in overcoming, I didn't put this in the interview, but to you guys of getting rejected from all the grad schools. Don't talk about that in an interview. But I just pitched that. And then in the interview questions, I really don't remember them too much, but being pretty confident in and that I'd answer them well. I don't think they were anything hard. It was like, okay, what's a left join? how many variable subsets are there out of if you have two variables, how many subsets are there? Being able to do that. So I would say at that point in time, I very much leveraged that one project, but it was extremely relevant. And I think part of the reason that was successful was that the job description was really close to my experience and the skills that I knew, having Python and MATLAB, as well as that, as well as a little bit of hands-on experience, was enough for me to get my foot in the door.
Right. So then you described a lot of the learning you had to do once you got that position. I guess I want to know once you maybe kind of settled into it a little bit more, how did you envision your career trajectory like going into the future? And having the two bosses, co-bosses, how did that work with like them helping you figure out, next steps to learn or ways for you to progress personally, like professionally in your career?
Yeah, I think once I had settled in to my position, and my dad says that it takes maybe like 2 years to get really comfortable in a new city or a new position, maybe 1 year in a new position, maybe like the older you get. But at that point, 2 years to settle in. And like when I moved to Minnesota, I didn't know anybody in the state at all. So it was a very big adjustment on that too. But once I got settled in, I was getting more confident and experience helping my boss develop statistical analysis plans, how we wanted to model up new projects, and then kind of taking the lead on that, getting into a good system of how we do reports, maybe different ways to improve it. I think the masters also really helped just kind of accelerate a lot of a deeper understanding of how projects should be structured, right? Through this all, I was always like right there with the clinicians that we were working with and whose data we were helping them analyze and going back and forth and just getting more comfortable saying like, okay, this is what I need from you. This is what I have questions on. This is how I can ask it and get that information, but also how to present and share it and kind of learning how they think and how they speak so that I could translate our results into the same way. So I think that was very helpful. Then my boss started also having me as she was looking to expand, and I think they had more funding to get more data scientists, go through, help interview new people to join the team. I guess before doing that, when she hired somebody, bringing them up to speed, helping them kind of develop and understand our code base and kind of how we approached projects, that led to then starting to interview people and helping my boss make decisions on like who would be a good fit for the team, helping her refine some of the interview questions that we had, and then go from there. That's kind of the extent of the professional development. I feel like maybe I think this is kind of also maybe around year 5 or so as I was getting toward the end of my master's. That's kind of when I was like, well, don't necessarily want to, I can't necessarily see myself staying here long term. I have not seen what the upward mobility would look like without a PhD here, for good or bad, right? Like I enjoyed everything I was doing. It was very interesting, but I didn't really see like where I would go at the university still. Kind of coupled with, I knew, MATLAB's probably not the most widely used data science tool in industry. And I picked up R along the way with this, and which is maybe more used in with more kind of stats heavy groups. But I was kind of still early enough in my career, and maybe still am, but still at that point, very or still early enough that I was like, okay, if now with the masters, kind of with a lot of experience, also working on all these different data science projects from start to publication, right? Because we were put that was our end product was is publications. From start to publication, it was like, okay, now's the time to kind of look and see what else there is where I can kind of expand that. And it kind of coupled with maybe a year before I finished my master's, maybe it was like 6 months before, my one of the professors, not my main boss, but the other professor I worked with, went on, she was having some medical complications. And so she went on leave for a couple months. And then when she came back, she was like, I'm going to leave academia. And I was like, whoa, this is a big shift. So kind of half the work I was doing was kind of gone, but they were very much reassuring of like, nope, you're gonna stay on, we're gonna figure this out. You have work on all these different projects. So and that was the case. So it was really good, and they took care of that, which was good. But it was kind of at that point with the masters, I learned how kind of is how to use neural networks to model from this because my master's thesis, and my boss encouraged me to do a master's thesis. My master's thesis was in comparing different neural network models to predict severe hypoglycemia, which is when your glucose level drops below a certain very low threshold, and seeing how many hours from 15 minutes before it happens all the way to 5 hours in advance, seeing how well we could predict that and comparing those to just kind of baseline logistic regression in a random forest. So it's like, okay, we were starting to move into, I don't think we ever really had enough data to fully utilize neural networks, but just kind of, that was kind of like maybe the last thing I felt like we would be learning, kind of the newest, being at the forefront of that. So there was some professional growth, I think more some softer skills and very much technical skills too. I shouldn't discount, I'm not trying to discount that. But I think I felt the point that I had all the technical skills that I was doing and where I could see certain projects going was maybe not the case to go further. So that's when I started looking elsewhere, and then landed in my current position.
So yeah, definitely, having career growth, being there for a few years, finishing a master's, doing the master's thesis, being on publications, all of that is great growth in a place. But I think yeah, it came to a reasonable time, right? With between folks leaving, you looking at hiring folks to almost replace you in some sense, right? Or advising on that, right? And also, coming to the end of the master's program. So yeah, certainly seems like a good time for a change. You start looking for jobs. Take us through that, right? So now you know, did you think about going to do a PhD in stats or CS or informatics or try to go back to astronomy and play that grad school game again? Did you think about applying back in Chicago or other places? I'm curious, you sort of had this, interesting winding path, and then I want to know those kind of details, but for the second job search, right? How did that go?
Yeah, for sure. So I guess let me start with did I ever consider applying back in like Chicago or anything? The answer is no, because let me see. So I finished my master's last February 2024. I got my new position. I started my new position September 30th, 2024. And I got married June 15th, 2024. So I started looking after I got married. And both my wife works in Minneapolis and her family's from here. I've really met a great community of people since I moved here 6 years ago. I was like, wait, maybe Chicago, but I very much was settled in Minnesota, did not see plans to leave. So I was looking to stay in the Twin Cities. Or, there are all these remote jobs now. So I was like, okay, maybe some of those, but I also very much wanted to stay within the medical field. So since I transitioned, I've just found it very fulfilling and very interesting. Fulfilling in that, like, we're helping people's lives get better, and interesting because this is kind of a new, data science being applied to the medical field is still really new. And working with real world data, real world evidence, especially in the medical field, is getting more. It's still in the relatively early stages. So I was looking for a similar position, but in the industry. And this job search was a lot more on referral based, how I ended up getting this, which as I've gotten older and talked to more people, yes, networking is very important. But it kind of came about organically because my I was living with four other guys from 2020 until 2024. And one of us moved out in early 2023 because he got married. And the rest of us, we all got engaged roughly in within like 2 months of each other. So we ended up, moving out at the same time and getting married between three of us had weddings from May 1st to to mid-June, right? So one of my roommates' wives worked at my current company. And so she had a couple, they knew I was looking, and she had this senior statistical programmer position come up. She actually referred me for another one, more on the business side of things, but it was maybe a stretch on kind of how it related to my skills. But this one was in the clinical operations department and much more closely related to work I've done in the past and a little unique as far as statistical programmers go, right? What I've learned is a lot of those positions are for FDA regulations and using SAS, like IBM's statistical software, which I've never used before. But I was like, well, I've learned all these other languages, what's one more? But actually, this position is unique because it's more on the data science side rather than traditional statistical programming. My company is looking to use electronic health record data, which has been parsed and cleaned by a large language model. And all of that data in their system is held together with Spark, and you interact with it using Python or R, right? Which just fits in perfectly with all the work that I've done before. And SQL too. And so it's more unique in those skills, right? And more matched with what I had done before. And also, I've realized in my last position, one of the big things I realized was how important it is to really clean and work through your data, especially the medical data. Because, like I said, you have so many different text inputs, and they're super messy when they all refer to the same thing. But if you just did a quick, string query for one term, you would be missing a whole bunch because of misspellings or abbreviations, all of that stuff, as well as like what are appropriate ranges for like systolic blood pressure, right? If you have something that's insanely low, right? Like, okay, this is a typo or they're dead. And being dead seems unlikely. So just having that experience before just made this transition really natural and easy. And I think also really having an extensive background now in programming from Python and R means that I can do this work a lot faster than someone else who's coming from SAS. So I explained all that in the interview, more or less, and talked about it. And then I got the position here, and it's fantastic. I love the company that I'm working for. I love my team. I like being hybrid still, which is nice. I've learned that having a little bit of variety in my working environment, whether it's like in the office or at home, just helps me stay really engaged. So I very much enjoy that format. Like I said, going back to the space exploration, like the adventure there, it's like okay, can't get too much routine from there.
Awesome. Yeah. We're getting towards the end of the episode now. What advice would you have for anyone who is trying to transition this year or next year? And especially maybe if they're trying to transition from a bachelor's degree into a data science position. Either one of those, what would your advice be?
Yeah. So if someone's transitioning now, I'll get to the bachelor specific case in a second. If someone's transitioning now, I would say be honest about what your skill set is and what these job descriptions require. Like there's still good stretches, right? Because Though you still see job descriptions that one person can't have all of this, right? Is kind of a wide net. If you're looking at like what your experience is and these job descriptions, like the best way is just having a good match and then being able to just talk confidently and just really understand what you're doing, really understand why you're using these different models, why the data needs to be cleaned this certain way, and really understand, frankly, cleaning your data. That's like the most important thing I think I've learned. Just really understand like all the processes and how much detail needs to be looked at for that. But then also, you know, I wasn't really like, I need to network with people in order to get a job. It was like, these are my friends, and my friends have really interesting jobs, and it's cool. And maybe they see something there and we can find it and say, okay, this is great. But like other people are really doing really interesting things. So just be curious about what other people are doing. You never know what happens, what could go from there. If someone's trying to transition from a bachelor's degree to data science right now, one, the University of Minnesota is hiring. Two, do you really have that hands-on experience? I think if you can go from getting comfortable working with data, whether that's in Python or R, I don't think it, as long as you understand the principles of working with data, when certain models are appropriate to use and not, when certain statistical methods are important to use over machine learning, right? That's also important to understand. How to properly evaluate is important. And then, obviously interpretation, being able to explain clearly to different people is important. But I was for bachelors, like, don't be afraid to take positions that lead you to data science, right? So like data analyst, maybe data engineer if you've worked more with databases. But I think a lot of junior data scientist positions are going towards master's and PhD people. And so it's maybe more rare to have the bachelor's. So like don't be afraid to just take a position that gets you experience, and then you can have the opportunities either at that company or a different company to kind of move more into the data science field. Like if you're coming out of bachelor's, you have so much time to get there. It's okay.
Thanks, everyone, for listening to this episode of the Astronomers Turned Data Scientists podcast. Please subscribe so you can find out when we release future episodes. And thanks again to Tom for joining us.
Yep, that's what I was going to say. Thanks again, Tom. Appreciate it.
Thank you so much for inviting me. This was super fun. It was great to chat with you guys.